Use the epsilon delta definition of limit to prove that limit of 6z minus 4 as z approaches to 1 plus I be equal to 2 plus 6i. In solving backwards, absolute value of 6z minus 4 minus 2 plus 6i is be equal to absolute value of 6z minus 4 minus 2 minus 6i. Simplifying, be equal to absolute value of 6z minus 6 minus 6i, and be equal to the absolute value of 6z and common term negative 6 times 1 plus I, be equal to separation of absolute value common term of absolute value of 6 and absolute value of z minus 1 plus I, and equal to 6 absolute value of z minus 1 plus I less than 6 delta, which means x is equal to z and c is equal to 1 plus I, so that an absolute value of x minus c is less than delta. Then absolute of z minus 1 plus I is less than delta. That's why is less than 6 delta, which is equal to epsilon, implies delta, which is equal to epsilon over 6. To prove, let epsilon be greater than 0. If absolute value of z minus 1 plus I is less than delta greater than 0, then take delta be equal to epsilon over 6. Then absolute value of 6z minus 4 minus 2 plus 6i is equal to absolute value of 6z minus 4 minus 2 minus 6i, which is equal to absolute value of 6z minus 6 minus 6i be equal to absolute value of 6z common term of negative 6 times 1 plus I be equal to separation of absolute value common term of 6, which is absolute value of 6, absolute value of z minus 1 plus I. Absolute value of 6 is equal to 6, and thus absolute value of z minus 1 plus I be less than delta, which means 6 delta be equal to epsilon. Therefore, the limit of 6z minus 4 as z approaches to 1 plus I is equal to 2 plus 6i. Evaluate the limit of I real part of z squared minus I real part of z plus imaginary part of z squared minus 3 all over absolute value of z as z approaches to 3 minus 4i. Now, first is we need to substitute the value of our z, which is equal to 3 minus 4i. Simplify the following. I real part of 9 minus 24i plus 16i squared minus I times 3 plus imaginary part of 9 minus 24i plus 16i squared minus 3 all over 5. Why 5? Because absolute value of 3 minus 4i is equal to square root of 3 squared plus negative 4 squared be equal to 5, which means the absolute value is given by the square root of the sum of squares of the magnitude of both parts, equal to I real part of 9 minus 24i plus 16 times negative 1 minus 3i plus imaginary part of 9 minus 24i plus 16 times negative 1 squared, negative 3 all over negative 5, all over 5. Simplifying the I squared, which is equate to negative 1, which is the complex number. I real part of 9 minus 24i minus 16 minus 3i plus imaginary part of 9 minus 24i minus 16 squared minus 3 all over 5 be equal to I real part of negative 7 minus 24i minus 3i plus imaginary part of negative 7 minus 24i squared minus 3 all over 5. and b equal to I times negative 7 minus 3I plus negative 24 squared minus 3 all over 5. b equal to negative 7I minus 3I plus 576 minus 3 all over 5, which is equal to 573 minus 10I all over 5. Separation of fractions, 573 all over 5 minus 10 over 5I, which is equal to 573 over 5 minus 2I.